Good morning, everybody. Thanks so much for joining us today. This is Sue Ewig, and I have the partner marketing responsibility for AI and machine learning at AWS. And I am thrilled that we have Pariveda on the phone today to talk to us about the work that they have done in logistics and transportation. And specifically, we have Ryan Gross, who is a principal as well as the machine learning lead at Pariveda Solutions. So without further ado, I will pass it over to Ryan, and he's going to take us through some of these great stories. Ryan?
Thanks, Sue. Happy to be on with everybody today. I appreciate you taking the time this morning to join on. Because we don't have a ton of people on the line today, I think we could take questions as we go through this. If you do have anything, feel free to unmute yourself and shout it out over the line. Otherwise, we can always take a question and answer session at the end as well. Today, we're going to be focused, like Sue said, on the transportation and logistics industry and how machine learning is impacting that. We'll tell a few stories of some work that Pariveda has done, as well as looking into the future and work we're planning to do with some of the new things that are hot off the press at AWS reInvent 2018. And finally, we'll finish off with a little bit on how do you get your organization started, as well as potentially how you can scale up if you've already gotten a start on machine learning. So with that, let's move into the presentation. So first off, the only slide here on Pariveda, we are an AWS Premier Partner, and this actually might be a little bit out of date with the new announcements at reInvent that these competency programs have grown, but going into reInvent, we were one of 4 partners in the US with all 3 of the machine learning, data and analytics, and DevOps competencies, which means we focus on kind of that data-driven value lifecycle. How do you take ideas that you have within your business, build data-driven solutions around them at scale, and then deploy those on the cloud into a production environment, which has given us experience across many industries. And a lot of the ways that we like to get started talking to our customers is through a series of workshops we offer with different flavors depending on where you are in your journey. Very briefly on me, I have 7 years working with Pariveda. I am about 3 or 4 years into the machine learning space, with many more than that working on data-driven problems and big data problems. So not a trained data scientist by background, but I would consider myself what we call an ML engineer now. You know, I can apply what's been done by data scientists. So briefly, this is just another view of the competencies that Pariveda provides and how they tie into that value life cycle of coming up from a problem to the data, to the models, to the applications that then solve that problem and uncover new ones. So let's talk about the impact of machine learning briefly. Broadly, AI-driven companies are expected to take, meaning to steal, $1.2 trillion of market share from their competitors annually by 2020. And that's across all industries based on a Forrester prediction from 2016. So you're talking numbers here that are higher than the market cap of any company on earth will be taken by those that get out ahead of AI from those that lag on AI. What I've always found really interesting was this report earlier this year. I'd love to find the follow-up that's hopefully coming out shortly. That this year, 2018, according to Gartner, AI-driven companies are going to derive 1.2 trillion in new value from AI. So that's value that they're deriving without having to steal it from their competitors, as well as that. But it is a acceleration of that trend from even the projections of 2 years ago. And so how are they doing that specifically in the logistics and transportation industries? If you look at another firm like Gartner and Forrester called APQC, their blueprint for success in logistics has called out that companies that are leaders in automating their logistics pipelines through AI typically have 264 less FTEs assigned specifically to logistics routing and transportation tasks than their lagging peers. And that's so all of these numbers are per $1 billion of revenue for the company. So you can scale this for your organization based on the revenue numbers that you're generating. They also realize $60 million in lower cost per $1 billion of revenue, which is a very substantial savings, and can be then turned around into competitive advantages in other areas. And the ways that they get that are both the FTEs as well as just completing their processes faster. So 3 times faster in receiving, 7 times faster in pack to ship processes. And then they also get it back in order performance. So top performers have 95% perfect order performance, meaning the right thing to the right place on time, while bottom performers come in at only 81% in that measure. So these are some real metrics that are being impacted by the ability of computers to do things at scale that humans once needed to do in a way that's very precise and that learns from what has happened in the past in order to be able to predict what's going to happen in the future. So how are some companies out there in the field actually doing this? We'd like to transition from that, there's a large impact out there, and start to focus on something real. So what are some real things that we at Pariveda have seen in the field of logistics and transportation companies leveraging machine learning to help improve their operations? And we've got 3 stories here, and then 1 more forward-looking story that I'll be sharing before we get into that how to get started and how to scale up discussion that's a little bit more theoretical. First one here is the ability to predict the demand for logistics services. In this case, we were dealing with a long haul moving company. So this is interstate moves of household goods as you move for your new job or to be closer to the family, making sure that your stuff gets there on time. But the problems that this company faces are very similar to what you see in almost any logistics network, and even within logistics departments at large corporate, large enterprises. So during peak moving season, Atlas Van Lines, who is our client here, had their agent network working together across markets in order to meet customer demand. They've been doing this for many decades, and the process that they were using was labor intensive and very heavily reliant on the wisdom of experts. So this is actually something that we've started talking to a lot of our clients on. If you have an expert who is starting to get silver in the hair and that you are heavily reliant on them, machine learning may be a good way to capture some of what they have been doing over the past 20 plus years as they've held a role, and make it more accessible to their future, the people who will have to do that in the future after the current expert retires. In this case, Atlas had a large set of historical data from their transportation management system that they had implemented in 2011. So all of that data going forward for every year up until the present. And so what we help them do, and what I think most logistics companies have the ability to do based on the prevalence of transportation management systems at this point, was build a machine learning model based on the historical data, the historical trend of demand, as well as a large number of additional features, things like housing starts, because that obviously would affect this particular industry. Housing sales, not starts, in each individual market, as well as things like how the calendar year affects this. So things like if the 4th of July falls in the middle of a week, the Monday and Friday of that week are expected to have extremely high demand. So creating features around those types of calendar things that are specific to your industry. And then allowing the machine to learn the historical patterns adjusted for all of the dynamics that were going on as those historical patterns occurred, let us build that model that was able to provide a heat map then back to their operations team so that they know which days within which regions have high demand. Now, because each of their different markets operate somewhat differently, instead of building just one machine learning model, we use the power of the AWS SageMaker platform to build 252 different models. So one for each region, for each date out into the future. So like I said, we use the SageMaker that to do our data exploration, and then the SageMaker platform to train the machine learning model. The execution of these uses AWS serverless technology, which means that Atlas has to maintain a very limited cloud footprint in terms of servers and patching, and their operational costs are very low for hosting this. And the value that is provided back to them is primarily so far in the operations side, working with them to quickly see which days are going to need extra attention, assign their resources, potentially reallocate trucks or hold trucks in cities for a longer period of time because we know demand is upcoming. But downstream, we're going to be working with this client to help their marketing team use this to start to direct marketing efforts to filling in projected gaps in demand, as well as working with their agent network and their sales teams to actually start to much more dynamically price things. So we'll get into that in our, what I like to call architecture diagrams here on the next couple of slides. So here's what the system looks like in terms of getting inputs into the algorithm and then providing the algorithm results back to the operations team. We take in historical demand patterns, details on the customers that are buying and the agents, and then build a whole bunch of customer features based on industry demand, timing, housing, so on and so forth. We use the AWS batch service to do something that's called decomposition. In this case, when you're building forecasting type models, it becomes important to focus on the things that have changed since the historical data happened. In this case, we're talking about a yearly cycle of demand for housing moves. So how is this year's cycle going to relate to last year? So decomposition breaks that down into what happened last year as one piece of it, the trend of is this year looking to be higher or lower demand just in general than last year, and then when you train the specific machine learning model on what are the residuals between that trend and last year's predictions that are going to be different this year. Or, the same thing could apply on a monthly cycle, a weekly cycle, whatever would be necessary. We then use SageMaker to train a model. All of the data and the model itself are stored securely in Amazon S3. And AWS Lambda is used to do some level of data enhancement as well as to actually execute the model. At the end of the day, we stand up an API that's called daily for generating this heat map that's presented back actually in Excel format, because that's very, easy to understand and use for the folks in the operations department. We also provide a dashboard that relates back the individual cells of this heat map to some of the key factors that led to the prediction being high or low for that area. So this is great for anyone that has to move goods and needs to be able to project what that demand is going to be so that you can manage your network weeks in advance, as opposed to doing that on a next week type basis in terms of feeling good about it. And also anyone who's currently relying on manual projections to make all of these predictions. It's going to be some of those FTEs you're saving and being able to reallocate to higher value activities. So expanding on this in terms of how we would use it for that dynamic pricing, which I think is actually an even bigger industry disruptive trend that will be coming. So on the left, you kind of have our historical model, a little bit simplified, removing the AWS batch step. And that gives you demand predictions. You can then use your historical supply, which is another somewhat complex problem, using a transportation network logs over time to know where all of the different assets, whether those are trucks or trains or whatever it might be for your organization, are likely to be at each point in time going forward. That can help you then build a model that will estimate the supply demand gap between, within each of your markets or regions or cities, whatever, however you'd like to break that down. And finally, you can bring in some CRM information around the specific customers that you're dealing with on an individual pricing order, so that this new customer can be then mapped back to a customer profile in terms of, are they likely to generate repeat or referral business, or is there something longer term with this customer, as well as the specifics of their order, like when it's going to be made, or how large of an order it is. You can then combine all of that information to guess at what the right price to win this customer would be, whether you should discount more heavily or discount less off of your tariff rates for each individual customer order. And again, you'd still want a key factors dashboard so that the sales folks who are using this are informed of all of the things that went into that decision, and still generally get the ability to make their own end quote to the customer. So the idea here is that by layering in and building out this capability within your organization, you might start with one model, but then once you start to layer multiple models together, you can do things that are just not necessarily possible in the current state of the industry today. And our projection is that these types of things will be right around the horizon. So, if we were talking this time next year, there will be companies that are starting to experiment with this through field tests, probably in targeted markets, as opposed to having this rolled out globally or nationally. But I would project that that will be the case within the 2019 calendar year. One of the other key factors in predicting your logistics and optimizing your logistics network is knowing where your channel partners, who are accepting a lot of your deliveries within a logistics supply chain operation, are going to be meeting that demand. And so this use case is probably most specific to those companies where the logistics department is serving the internal business more so than it is serving the, a broader, third party type of organization. And in this case, what we're talking about was a similar process, right? Trying to project the sales of individual items at a specific channel partner over a specific period of time. And the process that you go through here is actually relatively similar. The challenging part is, rather than just trying to predict individual demand, what you're trying to get at here is how can you optimize your warehousing operations and those sorts of things so that you have the right mix of product, or the items that will be shipped, at the right place in the right time to get to where they need to be. So again, we use the SageMaker platform trained on historical performance, as well as a number of indicators around marketing, promotions, and the actual sales volumes in general for those retailers, wherever they would they actually provided that information, and built another model that ended up pushing out results in Excel, so that the team can end up saving 10 weeks of effort each year in manual process to actually go and make these estimates, but more significantly, save something on the order of $1 million in the carrying costs within their warehouse operations. So rather than needing to keep a ton of individual items in stock in order to be able to get them shipped out, they are moving to a much more just-in-time process that's probably more familiar to a lot of the third-party logistics customers who are out here. In this case, again, we use Lambda step functions. It's the SageMaker platform with its built-in deep AR algorithm. What was nice to see this year at AWS reInvent is AWS has launched a new service called aptly Forecast, and it will take this even to kind of the next step of self-service, where as long as you have the data and the data is modeled appropriately, the forecast service will do a lot of the work that had to be done by Pariveda data scientists or ML engineers in this case, in order to properly format the data and run it through a known algorithm. So this case and the demand prediction before have gotten much easier just in the last week, or I guess will get easier. Right now you can apply for the preview of the forecast service, but going into next year you'll be able to sign up for the generally available service and experiment with these types of use cases even more. So showing a little bit more of the complexity on this one, wanted to show a little bit of how we are building this out. So again, we're using AWS Lambda for a lot of the preparation. We're using the batch service with Docker for data preparation. And then we're orchestrating across the thousands, in this case, of different machine learning models that are trained by the SageMaker platform and stored out on AWS S3 in order to make individual predictions. So if you think about the last diagrams I showed, this is kind of the blown out version of those that shows the next level of detail. So all of the data preparation in order for it to be ready to go run through the machine learning model happens in both this batch step as well as somewhat in the AWS Lambda functions. The predictions are then loaded. Each individual model gets its own instance of a Lambda function, and that's automatically scaled by AWS. There's very little effort on the part of the client or Pariveda in order to make that happen. And downstream, the aggregation happens automatically as well within the Lambda function, so that at the end of the day, each individual team that's responsible for a product, so if you have different divisions for different products and you're trying to manage the logistics of those, each team gets their own notification that their results spreadsheets are ready. They then use that along with the BI tool for that key factors dashboard. So end to end, both of these projects, in terms of building the initial version of this out, took about 8 weeks. And on this particular one, there's been several more rounds of optimization around specific retailers or specific product lines that have gone on after that to further tune the model. But the ability to have this type of system up and running, all the way from just the idea existing through capturing the data, building the models, iterating on the models, building the production system, can happen in as little as something like 8 weeks. Next thing we want to talk through is predicting the ship date on back orders. So, back orders is what we were focusing on here. This could easily apply to any type of delayed shipments that are already being tracked, but using machine learning to get that extra degree of nuance and confidence around when that product will end up in the customer's hand once something has gone wrong. So in this case, we were working with a medical supply manufacturer that also has a large distribution network that they run. They used a lot of phone calls from really dedicated people in their warehouses and procurement and customer service departments in order to figure out the actual projections once something went wrong within their supply chain. In this case, because we're talking about medical supplies, these were going to hospitals, and so having an accurate date, if I tell you something's going to be here tomorrow and it doesn't come for 3 days and you needed it to run a life-saving medical procedure, that's a major problem. So they were overly cautious in the way that these projections were being made. And I see this, personally with shipments, even just from companies like UPS, if they get delayed, typically the result I get is, oh, it's going to be delayed for a while, and then it ends up showing up much faster than that. So the machine learning solution that was built relied on historical performance, taking into account many different factors, including the customer who was being shipped to, the size and the relationship of that B2B relationship, and how that was being leveraged in the past by the people making the phone calls to get those shipments out, as well as things like the conditions in that warehouse, the status of all purchase orders for anything that may be used in order to get it into your your inbound logistics side, so that you can project your outbound logistics. Eventually, those predictions were integrated into some existing reporting, and the key here was we were just taking the same thing that was already done manually and slowly making it more accurate and faster with machine learning. So the model that we built used boosted decision tree. It was basically trying to predict the number of days into the future that the shipment would be delayed. And then the results for this were hosted on a web service, and currently they were being leveraged through batch jobs that would call into the web service every day and build that order report. But in the future, they could be used for live on the website or live tracking type predictions that a same API could be called. The key is getting all of the right input data together in one place. So it's more of a data platform problem for this company in order to be able to make this a real-time solution. As a result, the estimate padding has gone down by orders of magnitude. So where typically things were being delayed, in air quotes, 7 days plus as a minimum, many of these will be now projected to be delivered next day with high degrees of accuracy. And that's allowed then a number of, one, better customer experience, but two, increased sales through those customers not needing to go to a competitor to get a product in time for their needs. In addition, it saves a lot of manual time, again, enabling this company to be focusing their people on higher value effort. And it does lead to higher uptime and perfect order performance, because the number of inquiries coming inbound has gone down. So the number of manual changes being made has gone down, which means that the overall complexity that's being managed outside of systems has gone down. So many layers of impacts to what seems like a relatively simple problem. So looking at the architecture diagram for this one, there's not a lot of difference, and that's something we actually talk a lot about in our technical workshops around machine learning. In reality, there's really only 4 types of problems that machine learning goes after, and your goal in running projects around machine learning is to reduce the data sets and results you're trying to get into one of those 4 problems. Those are regression, which is predict a number. That's this one, trying to predict the number of days into the future that this order will be delayed. Second one is classification. That is trying to put something into a group, which a lot of times is as simple as a true or false question. In this case, we could have shaped this as true or false, this order will be there within 3 days. That's a classification problem. There are many other grouping type problems that have many more groups. One of the easiest ones for people to understand is image recognition, right? What are all of the different things that are in this image? Next one is clustering. Talked about this without calling it out by name a little bit on the dynamic pricing, where if you have a new customer, you can use clustering to find segmentations that may not be obvious on your current customer base in order to slot this new customer into a specific group. And you can then project the behavior of this customer based on something that's borne out by the data as opposed to just a more basic traditional demographic segmentation. The last one is anomaly detection, which actually could be something, and it is something we're talking about with this customer, of allowing you to detect things earlier in the process by figuring out which ones of these orders does not seem like the other orders, which would then make it much more likely to be delayed in the first place. And you could start to assign reps or people's time to focus on those orders without them actually being delayed just yet. So if you're looking at this from a all the way through logistics perspective, some things you would add into the problem are weather and road conditions and things that might actually affect your shipment while it's in transit. Then the same process could be applied, and potentially you could use a heat map type view in that case to show those things that might be impacted again in the future. So you have your projection of when you're going to be able to get it out of the door, but you need to then project when it's going to get to the customer's door. And heat map's a good way to visualize those orders that might need additional focus to further improve the ship date so that you can further improve the arrival date. All right, I know that was a lot of information in a short period of time here. The next thing to focus in on is those things that are becoming possible now that even 6 months ago were not really possible. So I'm calling these new world ML in logistics as opposed to real world ML in logistics on the slide here, because these are things that will become more commonplace over the next year. And I'm really going to focus in on one of these based on an announcement at reInvent, although there's plenty of other ones in the computer vision space, I think, that will also come to fruition. So the problem that I want to talk about related to this is how do you assign each of those loads to vehicles in a real-time manner? And how do you then optimize the routes of those vehicles so that you can come to some sort of close to optimal loading and routing path, which can allow you to then ship the same amount of goods with a much lower footprint in terms of both labor and capital assets like trucks, trains, or planes in order to get the same results. So every day, logistics and transportation companies have these really complex assignment problems, whether that's shipment loads to trucks or passengers and crews to planes, or what's going to go into the cars of a 5-mile long train. There's a high cost to mistakes, and there's extreme levels of complexity as things change on a regular basis. Minute by minute, the problem has changed. But if you're thinking about solving it with traditional optimization techniques, the solution itself might take hours to come to. One of the things that we've seen is that many of these companies out there have implemented simulators that allow their teams that are responsible for doing these operations to simulate the downstream impacts of the decisions that they're going to make. And the goal in implementing those in the first place was to allow people to, in real time, understand much more than they would be able to get into their own head based on the complexity of, if I assign this plane to this new route with this set of passengers and this crew, then that same crew can't do what they were originally supposed to do, and that propagates out through the network. What I think is really interesting here is the concept of reinforcement learning. This is one that you may have heard about in terms of computers getting really, really good at playing board games or video games. The most recent famous examples were AlphaGo from Google's DeepMind group that beat the world's greatest player at Go, which is one of the most complex board games. And then even more recently, the OpenAI Foundation, which is a open project, but a lot of the money comes from Elon Musk, beat a team of 5 professional video gamers at the game of Dota, which is a very complex team-based, fast-moving video game. So 5 AI players beat some professional teams of 5 human players. And what's key about the reason you've seen this used specifically for video games so much is because video games, by their nature, are a complete simulation of the environment that you're acting upon. The video game environment is the environment that you're acting on, so all of the information is available to you digitally. Now, in order to apply that same thing in the real world, what you need is some sort of simulator that accurately captures the impacts of decisions in a simulated fashion on real world behavior. Biggest example that you hear for this is self-driving car technology, where you're using visual sensor data to translate the real world into, images of the real world into data, and then a reinforcement learning model is being used in order to make the right decisions to get the vehicle to the destination as fast as possible while avoiding all negative outcomes. And so the concept of having a simulator is the key thing here. We've been talking to a lot of our clients recently around things that can be simulated. Within the logistics space, this seems to be one of them, that dispatch and assignment simulator system can be hooked up into a reinforcement learning platform so that instead of needing to solve a global optimization problem, the algorithm can just be fed the current state of the world and potentially several of the, how that has changed recently so that it can get a trend towards the way that the world might be changing over time. And it can then make in real time, based on having run through the simulator millions or billions of times during the training process, make an optimal decision of what to do in this case that will likely lead to the downstream results that you're looking for. So in this case, you feed in the historical events that impact the context, so that state of the world, and then you allow the reinforcement learning model to make an action, and you reward it if the result is good in terms of, in this case, all of the goods are delivered within expectations, and then you can continually kind of move the goalposts on it in order to say you will get rewarded now only when you're getting more and more optimal solutions. So then you can integrate that back into your runtime systems by presenting it with that same basic setup of the data you have about the current state of your network. And instead of having to solve an optimization problem, it's just going to use those historical scenarios that have played out to predict what is the next best action to take. And that can happen on a continuous basis. So in this case, we think about this as a 2-step problem. You gotta, we're using the trucking example here, but this could be planes or whatever else. First, you have to match the right orders to the trucks. So you create that dispatch plan. And then after you're doing that, you can optimize the schedule of those trucks getting to the results that you need. So reinforcement learning is primarily focused on the first one, although you could use this on an end-to-end solution so that it's recommending both of those things using reinforcement learning. So if you look at what this actually looks like, you maintain your current state of the world. So where are all of the trucks? Where are delays? Where is traffic? All of the different digital information that you can have. What is the weather now and the forecasted weather over the next period of N hours that is your time horizon you're looking at here. And based on a deep learning neural network that has actually learned from the millions of training runs what results have led to the most rewards over time, you make predictions of, in this case, predicted values likely will then be assigned back to, numbers that map back to orders being loaded onto trucks. So each assignment given a number so that you can then translate that back into a real world action. So the process of running this, you make all of these assignments, you then run those through the simulator to see what the impacts are, and you get your next set of state. You make a new set of assignments, see what the impacts are, get the new state, and you run that millions of times via the simulator so that when the real world version of current state shows up, it's just simply flowing that through the nodes in this graph and making those assignment decisions automatically. Now, up until reInvent this year, setting up a reinforcement learning environment was an extremely complex task, and that's why you only hear about companies like OpenAI or Google or Amazon going after something like this. But with SageMaker's RL service, RL obviously standing for reinforcement learning, you have access to pre-configured reinforcement learning environments that you can then tie into your simulator. So you can bring your own simulator, or if you don't have one now, you can use one of these open source or MATLAB tools in order to build one new. Most of the time right now, Pariveda is focusing kind of on companies that have the bring your own modeling environment or simulation environment. But everything else that's necessary in order to make that happen is being provided by AWS within the SageMaker platform. All right, so hopefully that overview of problems that can now be solved via machine learning has been somewhat helpful. Like I mentioned before, there's a lot of work that could be done with computer vision, which is using cameras or video feeds or images in order to detect what's happening in the real world in real time. There's a lot of opportunity for that within the warehouse, in the picking process, in the inspection process of any damaged packages, those sorts of things where you can just use the pixels of an image to do what a person used to be doing. Next thing I want to focus on here is how do you get started with this? So I listed 3 different examples and then one, more forward-thinking example here. I think that there are a myriad of additional opportunities out there. So how do you, as an organization, get yourself ready to do this? Well, first thing we like to think about with our clients is what stage of adoption of machine learning are you at right now? A lot of the customers we talk to are in these first 2 buckets of either this is the first time they're looking at this, or they've got some project that they're piloting, they're starting to build out, hire somebody in to get themselves started, but they're just trying to figure out how to use those MVP solutions. And then others, though, have been doing this for a year or 2, and they're starting to build out the platforms, they're starting to plan out the processes in order to do this at a higher scale. Typically what we see is at this early forming stage, you should probably only go after 1 or 2 things at a time until you're feeling a little more confident. As you move it into the storming stage, maybe you've got 2 to 3 things that can be handled at once, and then that ramps up very quickly as you move through and build out the capabilities over time. So when you're looking at these next couple of slides, we're thinking about those that are kind of over here on the left, and then the next steps after that will be over here on the right. So first off, if you're wondering whether this is for your organization at all, there's a lot of reasons that we're hearing out in the market, right? You don't know how to find the value. What are the right things that you should be going after, and are they actually going to pay off? That you don't feel confident you'll be able to hire or justify the cost of expensive data scientists coming out of PhD programs or master's programs. That you don't have either the IT or business capabilities within your organization to do that, or that in order to get all that data wrangled into the right place, it's going to take too long. You're going to have to build this data platform for a year and a half, and then you can get started. And all of these, we call them perceived challenges because all of these can easily be solved for via process and technology that's now available to you. So the way that we think about this is utilizing quick prototyping in order to figure this out. So we run 3 continuous loops to help organizations move their predictive analytics or machine learning problems into production in a way that ensures that you're along the way putting checkpoints in that you're going to get the value back out of what you're doing. So first one is identifying problems where you have the opportunity to apply machine learning, assessing those for feasibility as well as complexity in terms of just how much effort is going to be needed. Then running through the experimentation and learning phase. It's both experimentation in that these are research type projects and you don't know that you're going to be able to do that the machine learning solution will actually work with the data sets you have available. But as you go through that process, you learn a lot about those data sets. You also learn a lot about which problems are going to be most impactful or most easily adopted for your organization. And so you get better at it over time. And then on the right, you're designing the production systems that host this, make sure that you know everything's running appropriately, but you're also designing the experiments that go out in the real world in order to get those solutions into the hands of people and make sure that the business hypotheses you started with back here are actually being borne out. So talk a lot about controlled experiments and controlled business experiments at that point. So throughout this process, it's got to be collaborative across the technology, the analytics, and the business stakeholders that all have a stake in the game of getting this value out of a data-driven solution. So next thing here is to move quickly. I mentioned 8 weeks as the time horizon on a lot of the projects that I mentioned earlier. We've seen as short as 4 weeks on certain problems to get them out there. And with some of the newer technology, you can get to the point where you have a good idea within that experimentation stage within probably 2 weeks now. So then you can prioritize what's going into that cycle and reprioritize as you are actually learning more about it. The key being that you have a backlog or stable of ideas that could impact your business so that you're going to be continuously moving forward those things that are likely to provide value. So at the end of the day, it becomes easier for you to champion machine learning at your organization because you're tying everything back to value and you're not asking for these astronomical upfront insights. Now, a tool that we use for this is what we call the concept card, and each concept itself runs through these stages, which actually map back to the loops that we were just showing. The ideate and prioritize are up in the front, research and prototype is the experiment and learn loop, and then the market test and release is the deploy, test, and run. So as you look at what should go into a concept, first you create the concept card that documents what the value will be. You then prioritize based on value and risk. You research to fill out the details and make sure that you're able to actually build the features you're hoping to be able to build. You market test once you've got the predictive aspect of this right to make sure that the behavioral aspects are actually being adopted by the people that need to use them. And then finally, you release that into the real world. So looking at what a concept card looks like, here's one where you are looking in a different industry, but a title that is generally covering the idea, and then a single sentence that talks about the result that you are driving for the end customers. So in all cases, we talk about two customers. There's your company, and then there's the customer that's going to be using this, whether that's an internal or external stakeholder. Those can both be split out from each other. So in this case, you're going to affect demand, which helps this energy company, but also saves money and energy for their customers in the field. You then take those two things and kind of drive them towards the middle of what are the proposed features that will enable you to get both of those sets of value. And finally, you focus down on the capabilities that your organization may or may not have, so that you're upfront about the things that need to be done outside of the predictive analytics or machine learning component of this. So by taking this process and then prioritizing these based on the value statements and some complexity analysis, you're able to handle pretty much all of these objections. So articulating the value is front and center on the concept card. It's a great vehicle to communicate this with executives as well as those stakeholders that are trying to buy this or trying to leverage what's going to be designed. By focusing on the specific ideas, you're able to build out your data platform iteratively. And for an individual concept card, you're able to do that complexity analysis around just the data you need in order to get that particular value done. So you can then build out the data sets that are under governance or that are under your data platform based on those things that are actually driving value. And then on the organizational side, the life cycle, the kind of the 5 stages that we showed before, helps you to pull in the right people at the right time so that you don't necessarily need a major formal operating process at those earlier stages in that forming or norming stage. So with that, very briefly on if you're moving into the latter half of the maturity cycle, how are the ways that you start to scale this up? So we already talked about concept cards and how those address the finding the right value. They can continue to exist in an organization as you move up to running, 5 or 10 of these projects, or even 20 to 30 of these projects in parallel at larger organizations. But as you scale up, you need platforms like the AWS platform and the SageMaker machine learning platform so that you don't have to hire as many data scientists with master's degrees or PhDs. In fact, that's why I've used the term machine learning engineer more and more. And you can kind of see the parallel there between the degree of computer science that was always popular and the job of software engineer that many people with a computer science degree end up focusing on, where the latter is applying the state of the art and the former, at least at the universities, position is defining the state of the art. Then on the business readiness, you can use that agile ML process that was going for one individual idea across all of these as a way to run your program management around your machine learning initiatives. And finally, for building out that data platform, Pariveda has a framework we call Data Forge that helps you provide the structure both on the technology as well as the interaction between the technology and governance processes, so that you don't get you don't start to get inaccurate results due to the fact that your data that is providing the training to these machine learning models is not in the right state, but also to tie it back into the ideas themselves so that you can define the components of the platform and the roadmap for the platform in a way that you're continuously deriving value from it. So last thing I wanted to call out here is that, like I mentioned, Pariveda goes to market with a workshop approach here. So these taste workshops, in this case, we're talking more about these bottom two, predictive analytics jumpstart and real-time ingestion, would be a good way to get started if you're looking to reach out to us. And then we have additional ML specific workshops and then engagement models that can be used, first off, for those earlier customers to prove AI and ML can provide value. In fact, we even have a quick start with AWS that uses the SageMaker platform in order to accelerate some of that process. But then for those organizations moving to higher levels of maturity, we have training we can do on the process side of this, on the model ops, so getting these things into production and running them at scale so that you know that they're running appropriately and you don't have to spend all your resources there, or on the data platform so that you can run this stuff at scale leveraging cloud technology. And that is everything that I wanted to cover today. I know we have just about 1 minute left here. I'm happy to stay on if people have additional questions beyond this, but I found in prior webinars that people like to ask a lot of their questions offline. So open it up to the field. If anybody has a question, be happy to answer that now.
All right, nobody's got anything else that they want to ask, and that is fine. I'm sure that Ryan is plenty capable and would love to take your questions via email if you want to get in touch with him after the webinar. I also wanted to say that this has been great. Ryan, thanks so much. I've gotten a couple of pings from folks internally who are really impressed with this presentation specifically and what you guys have done around logistics and transportation. We will be doing a couple of things after this. If you are thinking that one of your colleagues or one of your customers might be interested in seeing this, the replay of this webinar will be posted on the Pariveda YouTube channel, so we'll promote it that way. We are also going to rerun it on January 23rd, which is a Wednesday. Same time. So if there are other folks that you think would be interested in seeing this, you can see it again on January 23rd. So Ryan will be speaking on that as well. We'll be covering some of the same material and hope that you can join us or help share this great content. So I think that's it for today. Thank you so much, Ryan, and everybody who joined. Hope you guys have a fantastic day.
Thank you all very much. Bye-bye.